Hey everybody, we're back and we're talking about section 2 of chapter 2. Remember, you're taking notes, and please label the top of your notes exactly the way I have mine. If you want to add the date, that's fine. So let's go ahead and get started. We're going to evaluate and graph polynomial functions today. And a polynomial is a monomial or a sum of monomials. Now, we talked about monomials before, that they are a variable to a degree of a whole number, okay? And then we can add them or add them to multiple monomials to make a polynomial. And a polynomial function, we usually look at it and it looks something like this. F of x, or some function, equals some term, and we'll call this a sub n. And a sub n just means like that's some sort of coefficient, and it's noted by this n means like it's the nth coefficient times x to the nth term. So that could, or the nth exponent, that could be an exponent of 1, of 2, of 10, of 20, whatever it is. And then it's added to the next coefficient. So a sub n minus 1 just means it's a different coefficient, and it's to the x times the n minus 1 power. So if this is n, let's say it's 10, that means the next term would be 10 minus 1 power, which is a 9. Okay, so that's what that means. We don't know the highest exponent right now, so we call it whatever the n value is. And then we'll do however many in the middle, and then we always end with a coefficient on x to the 1 term and a coefficient here. And this is our constant value, okay? Or we can say constant term. And you should be writing this down in your notes. Again, this right here, a sub n, is called the leading coefficient. And this right here, this n is the exponent. We call that, the highest exponent is also the term called a degree. And the ones that I've just highlighted here are really important. Constant term, leading coefficient, and degree. Those are all really important, and you'll see why in just a minute. We're going to go ahead and make a chart where we know our common polynomial functions, okay? A degree would be if we had x to the 0 power, aka we call that a constant. Whoops. And it would usually look like f of x equals what we would call a sub o, or you could say f of x equals some number, some value. And the example of that would be like f of x equals negative 14. It could be any number. That's what we call a constant function. The next one with a degree of 1 is called a linear function, and that could be written as f of x equals a sub 1 times x to the 1 power, which is invisible, plus that constant term on the end. And we'd say the example is f of x equals 5x minus 7. So if we see something that looks like that, again, this is an invisible 1 on the x. We call that a linear when the degree or the highest exponent is 1. Let's look at the next one. We call anything to the degree of 2 is quadratic, which we've used extensively, especially recently. And our standard form of a quadratic function is, we've been using ax squared plus bx plus c, but another way to say that is a2 times x squared plus a1 times x, and a sub o, that just means those are your constant term. And your example could be f of x equals x squared plus 2x minus 1. Okay, it could look like that. Let's look at to the third power, or the degree of 3, is a cubic function. And the way that we'd call that is a3 coefficient times x to the third, a2 coefficient on x squared, a1 coefficient times x to the 1, which is just x, plus that constant term. So for example, you could have f of x equals 3x cubed plus 2x minus 1. That would be a cubic function, again, because your highest exponent is 3. And our last one is called the quartic. Now there's more, but these are the most common. And the way we write the quartic function is, we'd say the coefficient a sub 4 to the x to the 4th power, coefficient a sub 3 times x to the 3rd power, coefficient a sub 2 times x to the 2nd power, coefficient a sub 1 times x to the 1 power, plus that last coefficient. And this example could be anything with x to the 4th as your highest term, and anything could be behind it, and it could have missing terms even, but as long as your x to the 4th is the highest, we call that quartic, okay? All right, so let's remind you. So remember, if we're evaluating something, a function directly, okay, so for example, if you have f of x equals 2x to the 4th minus 5x to the 3rd minus 4x plus 8, and I want you to evaluate when x equals 3, the way we would evaluate this is as I would say, okay, I want to find f of 3. And every time I see x, I'm going to replace it with the 3. So instead of x cubed, I'm putting in 3 right here. And then we're going to simplify this. So I know 2 times 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 again is 81. 3 to the 3 is 27. 4 times 3 is 12. And now I'm going to simplify this. 2 times 81 is 162. 5 times 27, ooh golly, what is that? It'd be 150 minus 15. I think that's 135. And I end up with a positive 23. Now, that's simple. We've always done that since, I don't know, pre-algebra, but it takes a little bit of time, and it's a little, if you make an error, you're in trouble. Here is a time saver. So this is something that you can use to save some time when we're evaluating functions, and this is called evaluating by synthetic substitution. So here's how you would do the same problem that we did up here in blue, but this is when we use synthetic substitution. Okay, so this is how you would do it. This is synthetic division, and maybe you've seen this or not, I'm not sure, but this is synthetic division. We go this value of 3, and we put it in the box. We're going to look through our function and say, okay, we've got x to the 4th, x to the 3rd. There's no x squared term, x, and they're constant. And then we're going to go through and look at the coefficients. So we've got 2 as our coefficient, negative 5. There's nothing on the x squared, so we'll put a 0 here to hold its place. A negative 4 on the x, and an 8. What we're going to do is we're going to list those coefficients, 2, negative 5, 0, negative 4, and 8. And this is our process. For synthetic division or synthetic substitution, which uses synthetic division, we always bring down our 2. Now, when our next step is, we always multiply what's in the box times anything on the bottom line, and we place it here. So we're going to go 3 times 2, and we put it here, and that's a 6. Whatever is there, now we add down. Negative 5 plus 6 is positive 1. And now we're back at that bottom line. So now I'm going to multiply 3 times 1, and we're going to put it here. 3 times 1 is 3. And now we add down 0 plus 3 is 3. Again, we're back at the bottom line, so now we're going to multiply 3 over here times this 3, we put it here, which is 9. Add down. Negative 4 plus 9 is positive 5. And we're going to multiply again this 3 times this 5, we put it here. And we get 3 times 5 is 15, and then we add down again. This last value is really important. This last value is called the remainder. And we have a rule that says if I want to know what f of 3 is, whatever the remainder is our answer. Okay, so whatever your remainder is in this process is your answer. F of 3 is 23, and let's go back up here. Oh, look at this. These are the same. We found 23 up here, and using the synthetic division process, we got the same answer. Now, it went longer because I'm teaching it to you, but when you do it yourself, it's really short, and it cuts down on some work, and it's a lot faster. Okay, so now we're going to be talking about what these polynomial functions look like when we graph them. And one of those things is we need to know kind of the idea of what they're going to look like before we graph them. So this is called the end behavior chart, okay? Now, the end behavior chart just describes the left and the right sides of the function. It does not describe the middle of the function. So again, these are just describing what's happening on the left side and the right side. Is it going up? Is it going down? What's it doing? So here's what we're going to look at. We're going to look at that leading coefficient, right? So remember, again, f of x equals a sub n times x to the nth power plus all the stuff. And then there's our last value is the constant, okay? So our leading coefficient is right here. Our degree is right here, so that's what we're looking for, our degree. And this back thing here, remember, we talked about that before. We don't need to know it right now, but this is our constant. Okay, so our leading coefficient, and we're going to note, we don't really care what the number is as much as we care if it's positive or negative. Okay, so we care if it's positive or negative. And then our degree, if it's to the 4th power, to the 5th power, to the 10th power, I care about if it's even or if it's odd. So those are the two pieces of information that we're looking at. And here's what that's going to tell us. Okay, these lines in the middle are just kind of to show you, I don't know what's going on in the middle, but if I'm looking at the left and the right side, this is what it's going to look like. Now, if it's a positive leading coefficient, positive means it ends happy or up. Okay, so if it's a positive, it ends to the right going up. If it's an even degree, it will match on the left and the right side. If it's an odd degree, it will be opposite. So the left and the right side will disagree. Okay. Now looking at this over here, if it's a negative function, it ends sad or down. So on both of our negative functions, they end down, meaning on the right side. Even, again, matches, so it's the same on the left and the right. And odds are opposite. So here's what that means, and this is what you're going to want to do. You're going to want to know this chart so well that you can recreate this so that you can see it on a test, because this is really going to help you. And here's what this means, okay? For this first one, I'm going to zoom in here. If it's positive and even, on the left side, we say it like this: as x approaches negative infinity or going to the left, the y value or the f of x value is approaching, look, see how it's going up here? It's approaching positive infinity. So make sure you've got that down. When it's even and positive, on the right side, as x approaches positive infinity, so it means as x approaches this way, the f of x is approaching, going up again, also positive infinity. Over here, If it's negative and even, on the left side, as x approaches negative infinity, again, that's this thing right here, f of x is approaching down, so we call that negative infinity. On the right side, as x approaches positive infinity, again, that's going to the right, f of x, which is the y value, is approaching this down, so we say that's negative infinity. All right, let's look at this one. If it's, again, this one's positive and odd, so for positive and odd, as x approaches negative infinity, that's left, the f of x is approaching down, so we say negative infinity. And as x approaches positive infinity, that's to the right, f of x is doing what? It's going up, so we call that positive infinity. And our last one here is negative odd. So as on the left side, as x approaches negative infinity, that's the left, f of x is approaching a positive infinity. And as x approaches on the right side, positive infinity, f of x is approaching negative infinity. So this is a visual representation of all polynomial functions based on their leading coefficient, positive or negative, and their degree, even or odd. Okay, so here's how to graph a polynomial. First, you're going to find your end behavior with your end behavior chart. So you should be able to say, okay, here's your chart, positive, negative, even, odd. Here's the middles. Positive always ends up, negative always ends down, even match, odds are opposite. Okay, you should be able to reproduce that pretty quickly so you can know what end behavior looks like on your graphs. And then to know what's going on in the middle, because remember I told you that's your end behavior that only tells you the ends, what's going on in the middle, you're going to make a table of values. So remember, table of values look like this, where you're going to pick some middle values, whatever that looks like. It could be -3, -2, -1, 0, 1, and 2, or whatever values you decide are appropriate. You can solve them directly or using synthetic substitution to find those values quickly. Okay, and we'll go ahead and do some of those in class. That's it for notes right now.